Did you know that AI can already drive cars, detect diseases faster than doctors, and even create realistic paintings? But what's the secret behind all of this? How does AI understand and learn to do all these incredible things? The answer is simpler, and cooler, than you think. It's neural networks. Imagine teaching a computer to think just like a human brain. Well, that's exactly what we're doing with neural networks. They're behind everything from the apps you use to diagnose health conditions, to those videos that recommend just the right song for you. But how do they work? Why are they so smart? Today, we'll break it all down and show you how these brain-inspired systems are changing the world. And trust me, by the end, you'll see neural networks in a whole new light. What is a neural network? Okay, so let's start with the basics. What is a neural network? Imagine your brain. It has neurons, right? And these neurons work together to help you think, see, and make decisions. A neural network works in a similar way. It's like a computer version of your brain. Input layer, this is where the data comes in. For example, if we want to predict if someone is healthy or not, the data might be things like their height, weight, and age. These are the inputs. Hidden layers, this is where the magic happens. The hidden layers are like your brain's thinking process. Here, the network tries to learn patterns in the data. It's not looking at the data directly, it's making sense of it. Output layer, this is the final decision. Based on all the input and processing, the network will make its prediction or classification. In our example, it might say, this person is healthy, or this person might need to see a doctor. How does a neural network work? Imagine you're feeding the network some data. For example, let's say we're using the features height and weight to predict whether a person is overweight or not. The input layer receives this data, height and weight. Now, each piece of data is multiplied by something called a weight. Think of weights like the importance the network gives to each piece of data. Maybe weight matters more than height for predicting if someone is overweight, so it gets a bigger weight. The weighted data moves to the hidden layer, where the network starts thinking. This is where the network learns patterns, like, hey, taller people with more weight might have a higher chance of being overweight. But this is just the beginning. The output layer then makes the final decision. It says, okay, based on everything we've learned, this person is either overweight or not. Now, the magic is that the network learns from its mistakes. It keeps adjusting the weights to improve its predictions. Let's say the network made a wrong prediction, it will learn and adjust itself to be better next time. Training a neural network. Here's where things get interesting. How does the network get better over time? That's where training comes in. Forward pass, first, the network makes a prediction, just like we did before with height and weight. Error calculation, then, the network checks if its prediction was right or wrong. For example, if the person isn't actually overweight but the network said they were, then there's an error. Backpropagation, this is where the real learning happens. The error is sent back through the network to adjust the weights. This process is called backpropagation. Iteration, this happens over and over again, millions of times, until the network gets really good at making predictions. With each round, the network gets better and better. Training a neural network is like teaching a child. At first, they might make mistakes, but over time, they get smarter. Real-life example. Okay, let's take a real-life example to see how neural networks are used. Imagine you want to predict house prices based on square footage. In the beginning, the network doesn't know much about how square footage affects house prices. So it makes some bad predictions. But through training, the network gets better at understanding how house size affects the price. After several rounds of training, the network can make pretty accurate predictions, even predicting prices for houses it's never seen before. This is one of the reasons why neural networks are so powerful. There's not just one kind of neural network. There are different types for different tasks. Let me explain a couple. Feed-forward neural networks, these are the basic kind, where the data just flows from input to output in one direction. They're used for simple tasks like classification or prediction. Convolutional neural networks, CNNs, these are used for images. They're really good at looking at pictures and recognizing things like faces, animals, or objects. They learn patterns in the images, like edges and shapes. Recurrent neural networks, RNNs, these are great for tasks involving sequences, like text or time series data. They remember past information, which helps them understand things like sentences or stock price trends. Each type of neural network is designed to solve specific problems. Isn't that cool? Now, where are neural networks used in the real world? Here are a few examples. Real-world applications. Self-driving cars, neural networks help cars understand the road, recognize pedestrians, and make decisions in real time. Medical AI, doctors use AI to analyze X-rays and predict diseases like cancer. Neural networks help the AI make these decisions faster and more accurately than humans in some cases. Social media, when Facebook or Instagram recommends posts, it's a neural network figuring out what you might like based on your past behavior. So, neural networks are already transforming our world in huge ways. Challenges and limitations. Even though neural networks are powerful, they do have challenges. Data, neural networks need a lot of good data to work well. If the data is messy or incomplete, the network won't perform well. Computational power, training neural networks takes a lot of computing power. For big networks, it can take days or even weeks. Overfitting, sometimes, neural networks become too focused on the training data and forget how to generalize to new data. It's like memorizing answers instead of learning how to solve problems. Alright, that's a wrap. We've learned that neural networks are like the brain of AI. They take data, learn from it, and make predictions. Whether it's recognizing faces or predicting house prices, they're being used in so many cool ways. And even though they're not perfect yet, they're getting better every day. If you liked this video, make sure to hit that like button, and don't forget to subscribe for more easy to understand AI content. And if you have any questions, feel free to drop them in the comments below. I'd love to hear what you think. See you next time.